Professor Dr. M. Sohan, Vice Chancellor of Rajshahi University. Presenters of this seminar, Dr. Usman and Dr. Mushfiq Ahmed, Secretary General of this seminar, Professor Dr. Ismail, scientists from home and abroad, lovely audience. Very, very good morning. In this fine morning, hundreds of scientists and people interested in science have gathered here enthusiastically in the Senate Hall to listen to two great scientists who have something new to tell, something new about theory of special relativity of the great scientist Einstein. If their findings become acceptable to the world community of scientists, then this event will be regarded and remembered as a golden milestone for science. And all of us present here will consider ourselves as proud witnesses of a golden moment of history. If not, even then, we will remember this occasion as courageous deliberation by two scientists who dared to think of novel ideas. Scientists are for finding truth, explaining it to others, and utilizing the findings for the welfare of mankind. A new theory may be accepted or rejected. Even if it is rejected, it is a positive development towards better understanding of problems under consideration. What is important is that truth should be revealed. A scientist's mind has no prejudice. He is free to accept or reject something if there are scientific evidences for or against something. Ladies and gentlemen, at this moment, I have only to say, let truth be revealed, truth be established, and truth be accepted. Thank you.
Honorable Co-Chair, Professor Mohammadullah, Honorable Vice Chancellor of Rajshahi University, our scholar, two physicists for whom this seminar has been arranged, Dr. Mushfiq Ahmed and Dr. Usman. In front of me sitting, the former Vice Chancellor of Rajshahi University, Professor Abdul Khalik, the Vice Chancellor of Science and Technology, University, Patna, Professor Muzaffar Hussain, Director of IBA, Professor Rajshahi Rahman, distinguished scientists from home and abroad, dear participants, journalists of print and electronic media, ladies and gentlemen. A very good morning to all of you and welcome to this Senate. It is my immense pleasure to say a few words about this international seminar on Special Relativity ISSR-2012. As you already know, this seminar has been arranged by the University of Rajshahi with a special mission, that is to create an opportunity for the two scientists, Dr. Mushfiq Ahmed and Dr. Usman of this university, to bring to light the results of their nearly 2 decades research on special relativity to the scientific people of home and abroad, and because the scientists have claimed that they have derived new equations which are missing in Einstein's model. They also claim that particle particle's velocity can exceed the velocity of light. And in support of this, they have made clear mathematical statement. They also say that this will not contradict the Einstein's model. Rather, the scientists claim that they have fulfilled the deficiency of Albert Einstein's theory of special relativity. Ladies and gentlemen, Rajshahi University Authority has just made a rule for the two scientists to let you and the scientific people of the world what they have claimed and what they are going to deliver in this seminar after this inaugural session. I hope you will find it useful, and I believe that fruitful conclusion will be derived. Hope your 2 days long stay here will be peaceful and enjoyable. Thank you very much. Thank you all and Sunday.
Rajshahi University, distinguished guests, ladies and gentlemen, please accept my greetings. Dear audiences, relativity is a little understood, very popular theory. The major hurdle on the way of understanding is that we do not know the problem it claims to solve. If someone claims to have found a cure for cancer, we understand at least the half of what he is saying because we know what cancer is. If someone claims to have found a cure for Alzheimer's, we are puzzled because we do not know what Alzheimer's is. It gained popularity because it is absurd. It imposes on us views like shrinking of space and dilation of time, which are against our intuition. 20th century, especially the first half of it, witnessed a trending for absurdity. From the day it was born, science aimed at certainty, and quantum mechanics is built on uncertainty. Franz Kafka, the master of absurdity, was one of the most acclaimed authors of the time. To make observation, especially in the domain of electrodynamics, motion of charged particles and rays agree with our understanding. Henry Poincaré and Albert Einstein proposed the theory of relativity. One of the postulates, something we agree to accept without understanding, of the theory of relativity is that the speed of light is not affected by our own motion. If a moving train is observed by a vendor standing on the platform, observes the speed, the same train observed by passenger in another moving train observes a different speed. The speed of the observer affects the observation. Not so in case of light. This is the postulate. Moving or not moving, it is the same speed. And it is the maximum. No speed can be greater than the speed of light. When a new medicine comes, it is usually received with enthusiasm. Then physicians try to see how it works in various situations and very often find undesirable side effects. About the same is the story of scientific theories. There have been problems, especially in the domain of this postulate. We have been trying for about 20 years now to reveal the theory of relativity without Einstein's postulate. We have also tried to integrate some quantum mechanical concepts, especially de Broglie's material concept, into the theory of relativity. Einstein's theory has given us some equations which Einstein said, place your hand on a hot stove and a minute feels like hours. Sit next to a pretty girl and an hour feels like minutes. Now that is relativity. It means that time in happiness passes very rapidly, but sad time passes slowly. Obviously, in relation with relativity of time, there are two situations which are completely opposite to each other. However, in his theory of relativity, Einstein has put forward a mathematical formulation to describe one situation only. We have derived two equations which can describe both the situations. One of them is exactly Einstein's equation, the other one is therefore the missing equation. Similarly, there are three more missing equations which we have also derived. In fact, we have derived those in three different ways. Lorentz and Einstein have given a transformation law for the relativistic addition of velocities only. We have found the relativistic addition laws for all other relativistic quantities. Further, we have derived the multiplication rule for velocities as well as for all other relativistic quantities. We have also found out the expressions for minimum and maximum values for relativistic quantities. The missing equations, together with the existing ones, complete the theory of special relativity. We are giving another set of self-consistent equations, which we have called non-Einsteinian relativistic case. The set of equations are directly related to the Galilean velocity and hence is applicable to all values of velocity ranging from 0 to infinity. These equations can resolve the dilemmas of neutrinos moving faster than light and can help overcome some difficulties the cosmological theories are facing. We hope to have covered some ground. Much more is yet to be done. We have been encouraged tremendously by our colleagues, senior and junior, and by the people around. The enthusiasm shown by the whole nation is much more than what we could expect and certainly much more than what we deserve. The media has played a forceful role in mobilizing this enthusiasm. Our gratitude to all is much more than words permit us to express. Thank you.
Thank you all. We will now give a break of 10 minutes for refreshments and we will be back here at 10 o'clock for the technical sessions. Thank you.
In its own domain, each one is a very successful case, relativity and quantum mechanics. We need an umbrella which can accommodate both of them. No. Number two, the relativity stands for Einstein's postulate that the speed of light is variant, and it also implies that it is the highest available speed. Some cosmological theories and also some recent observations question the validity of this postulate. We will be very happy if you can develop the same theory or similar theory with we're trying to solve. Reciprocal symmetry. It can vary like this. It can vary like this. This side's together. For this paper, number one, reciprocal symmetry, RS stands for reciprocal symmetry, as the bridge between relativity and quantum mechanics. Number two, to present RS as the substitute of Einstein's postulate. Number three, to present RS as the basis for reporting every velocity u, which is x by t. We can define the slowness, which is at the reciprocal of the velocity u, which means that it equals. Physics is independent. Physics is independent of the way we describe. The principle of objectivity demands that the description in terms of velocity should be as valid as the description in terms of slowness. The objectivity of what we call nature So it is not changed by how we look at it. So the description in terms of speed is as good as the description in terms of slowness or vice versa. From mathematical point of view, every number has a reciprocal. Usually we represent quantities by numbers themselves, 1, 2, 3, 4, etc. Nothing stops us from representing them by the reciprocals of numbers. Instead of 1, let's say 2, we put it half. Instead of 4, 1, 4, and so on. Because there's one correspondence between number and its reciprocal. So that is as consistent mathematically as numbers themselves. This reciprocal representation should be consistent with the representation by numbers themselves. This is the get it? Valid description if we use reciprocals of numbers instead of numbers themselves. If a velocity is represented by U form dimensionless quantity V by C, this link is not distributed. This V by C, we want to make dimensionless quantities so that we can further integrate with numbers. We do not want a dimension. For this, we choose a constant speed, in this case C. It will later we shall see that this speed, this C corresponds algebraically only with Einstein's C. But we are not assuming any physical meaning to it. So this corresponds that there is a relation between Planck's hypothesis and Einstein's postulate. We would like to see this a bit more in detail. So we define an energy PU as U square, which is double the usual kinetic energy. And EC will correspond again MC square. If U is less than C, which is the Einsteinian velocity, therefore is less than C. In that case, EU will be less than or equal to EC corresponding to U less than or equal to C. The reciprocal energy will be just the other way around. Instead of less than, it will be greater than. So, if we define a reciprocal energy, it will be greater than EC corresponding to U star greater than C. And he did it in terms of a higher quantity which has a low element. When you go to gain or loses energy E star, the gain or loss cannot be less than EC run to low element. Planck's hypothesis in Einstein's picture can invert it and divide the reciprocal energy. So if Planck's energy is star, then corresponding reciprocal energy we got without star, U only. In this case, Einstein postulated that speed cannot be greater than C. The same thing we can say in terms of slowness or reciprocal speed. The reciprocal speed cannot be less than C, and this again becomes like Planck's statement. So we call it Einstein's postulate in Planck's picture. Discrete separation between energy levels is at least greater than EC, because in Planck's picture, all energies are always greater than EC. So in that case, if we take any equivalent energy level, the difference is also in energy. And since energy cannot be less than EC, it has to be greater than EC. The difference between any two energy levels is also greater than EC. Therefore, reciprocal. If we replace the velocity U by U star and V by V star with the reciprocal velocity, our postulate is that it remains invariant. Sum is invariant. We shall try to replace Einstein's postulate by this reciprocity postulate. And if you can develop quantum mechanics or kinematic with this postulate, then we shall have achieved in developing kinematics without Einstein's postulate. These two, we got this relation, and from these two, we get this relation. So which means, now if we put C here instead of minus C. And reciprocal of B star is C star by C. So therefore, if B is C, C star is also C. So if we replace this B by C, we get minus C here and also minus C here because of C values. Which means right hand side and this side are the same. That gives us that U is equal to U star. And if U is equal to U star, then U must be C. So we proved out here from reciprocal symmetry that if addition is motion in one dimension, we shall look for an additional representation of function which satisfies this postulate. We said that we is some sort of addition, but we do not know what that function is. And we want an addition to fulfill this postulate. So we find that this is a possibility. This is an addition which fulfills this first postulate, which is to replace U star, V star by U, V by U star. We get the same thing right now. Simple as that. And also, we find that if the reciprocal of this quantity is also another condition which fulfills this postulate. So either this or the reciprocal multiplied C square by this quantity. So both this addition and also this addition are both the possibilities of candidates for which fulfills this postulate. So these are the two additional laws we have to have. The first one, there. This one is Einstein's law of additional velocity. So we have developed from Einstein's law of additional velocity. When we remind the law of additional velocity, which is the reciprocal of Einstein's law of additional velocity, and that satisfies the closure relation is that is the sum is greater than or equal to C if U star is greater than C or V star is greater than or equal to C. The relation between continuity and discreteness. And we have seen that continuity is continuous, it is normal representation, gives a discreteness and is reciprocal representation. Now we should try to see this reciprocity and the correspondence between them more closely. Correspondence between reciprocity and discreteness done by Mr. Gamma and Dr. Hamilton. The objective of this paper is the next paper now. What is it? When Kelly kind of, V is the constant velocity, T is time, and distance is just x equal to V. We shall have to define a length like we define a C here to make speed dimensionless. Also, we shall make length dimensionless. So, what is corresponding to C, we define an LCT. It should be consistent with the R quantity, so this L should be equal to C multiplied by T. C is a constant, T is a constant, and L is a constant. This permits us, this is just a mathematical equation, D by C equal to progression from U plus D by C and a root 2. This is if D by C is tan hyperbolic of D by C. Just a mathematical identity. And we call this quantity C, is a definition of V by C. Now, to find the distance separate, we multiply this distance V by C by this quantity T by T. So V by C multiplied by T. The numerator will give Vt, the denominator will give Ct, which is L. So we get now X by L, and this simple multiplication comes here, we replace the logarithm because the power. And this variety in this form, this is called again x by l. X by l will be this, which is defined by this. So x by l will be logarithm of c, small x by l. And big V and small v are related to tan hyperbolic transformation. Similarly, this x and this small x will be correlated but a similar hyperbolic transformation. X is the distance covered in tan t by velocity v in meridian differentiation, and small x is the distance covered in tan t by velocity v in hyperbolic. And if you work out the definition, this small x by ct comes out to be simply this thing. Now we try to see what it means in meridian space that we live in, especially in the special limits. We get meridian limit if c goes to infinity. What happens is this quantity, when c goes to infinity, and if we work out the algebra, in this limit, x becomes small bt. So we are again find the usual relation between velocity and distance as distance the product of v and t. And further, if c goes to infinity again, then this hyperbolic transformation gives identity and vt goes to becomes vt, which means we agree with our Galilean definition of distance covered by time in this limit, but we have this definition of time now. And now to correlate, we should try to go to the reciprocal space and see how it behaves when v by c is replaced by the reciprocal. Using the reciprocal velocity, v by c equal to v star by c. We start reciprocal v, which means c by v. We define reciprocal distance z in place of x. So here we have x with z here. And in this place, instead of v by c, we put c by v. This gives us reciprocal using this transformation. This becomes v star by c into c by v. And we get the whole thing there, c by v here, and it is v by c here. If we take out this fraction, minus 1 to the power of this power. So it means for even quantity back. When it's even, this just becomes 1 and we get the whole thing back. Where what we had before, that z is equal to x. When z is equal to x, when it is even. When it's a odd number, it is negative, and that is the reciprocal, which is in this case, z by n becomes x star by n, the l by x, that is the reciprocal. So, we found that discrete time, t by t, with discrete or even, they give real distances. One is direct distance, the other is the reciprocal distance, and when t by t is non-integral, attraction gives a complex distance that is complex. Now, what we want to see is the correlation between discreteness and reciprocity. And we will achieve in finding that our reciprocal symmetry gives us in the reciprocal speed a value for the distance covered in terms of discrete quantities. Either time is discrete and also it implies that distance covered x is also discrete. For this, we start with some definitions and some simple mathematical identities. This is an identity. This can be also in this form, it's not by 2 here, it's just a delta here, it's a double here, it's a diameter is not there, and we define this quantity. So again, we see that if we add I plus t to this lambda, we get this quantity from this case, if S is even, we get the same thing back of even integer. If this S is odd, we get the reciprocal. So again, if S, depending upon S, so that even integer or odd integer, we get the same thing back or the reciprocal thing. And for non-integral, we get other values, complex values. Now we come back to Planck's relation. This quantity, if we replace this Planck's function, which is essentially Boltzmann's function, which was used in Planck's theory, if we replace this quantity by negative reciprocal, so instead of E, we want for E, and instead of 1 minus 1, replace this with this, we get this quantity. And if we replace minus omega by omega prime, we get this thing. So this corresponds to this relation. Instead of minus here, it's plus here. And this Boltzmann's function. And Boltzmann's function is the solution G of this differential equation, which can be written in this form. This is Boltzmann's function. We have written instead of h omega, h can be excited, but essentially it's this function. Now, to find the reciprocal parts, we replace this differential equation by this finite difference equation. The delta plus and delta minus.